Hi guys, I really feel that this is a pretty good problem because it checks whether you are able to recognize exponential function from a table or identify whether it is exponential or linear. So let's begin with this. So x values are really nice. They're just differ by 1, 1, 2, 3, 4, increase by 1, right? Now let's take a look at how much changes are there for each change in x value. So take a look at from x increases from 1 to 2, h decreases from 70 to 49. Well, when x goes from 2 to 3, here this goes to from 49 to 34.3. If you do a little simple math, this doesn't like here decrease by 21. And here, what do we have? It's like 14.7, right? The decrease by 14.7. So because of the decrease, and by the way, here is just about 10.99. So 10.99, the decrease is 10.99. By looking at the amount of decrease, I know it's not going to be linear. Being linear, suppose this is 1, 2, 3, 4, okay? Being linear, the decrease, if this is 10, this is 8, the decrease by 2, the next decrease must be the same as 2. So if you have that, that will be linear, okay? The decrease is constant, will be linear. Uh, Now here this is not, and then if it's not, let's take a look at what kind of decrease that we have. If you look at here, you can see that 70 times zero point 0.7, you get the 49, right? So you see that if you multiply 70 by 70% of 70, you get this one. And then let's check again. This time, multiply 49 by 70%, which is 0.7. You actually get to 34.3 if you do the math. Okay. So, in other words, you do know that to get the next value, you just need to multiply by a constant, multiply, not subtracting, but multiplying by 0.7. So it seems like that's the characteristic of exponential. In this case, exponential decay, because this is zero point 0.7, which is a number less than 1. So with that information, let's read. The table represents an exponential function because the function values decreases by a constant percentage. Is that right? Is that right? So I would say yes, it is right because it's decreasing by a 70% from previous one. The next one is let's take a look at which function describes the table. If uh, how do you check? It's fairly easy. You just simply plug in a value into your function. So for instance, when x is 1, the output should be 70. So if you choose this one, when x is 1, this is 0.7. Obviously, you're going to rule this out, right? If you look at this one, when x is 1, you get 100 times 0.7, which is 70. Seems like this matches the table. So now, based on the discussion, we are going to rule out the linear function, okay? Linear function. And then here, the very last one represents a function that is neither linear nor exponential. We already recognize it is exponential. So I hope that this discussion will help you complete this question.